So thank you all for joining. I'm Abby Lindberg. I lead GelSight's applications engineering team. Before we get started, I'll just make a couple announcements. We'll be recording this session, so that we'll post it to YouTube after this if anyone needs to leave early or anyone couldn't attend. And we'll also have the Q&A open throughout the webinar. So Frank Chang from my team will be answering questions live while we go through the presentation, and then we'll also cover any questions at the end as well. So with that, I think I'll pass it over to Thierry Montel to introduce himself and get the webinar started.
Yeah, thank you, Abby. Thank you very much. Hello, everyone, and welcome to this new webinar. I'm Thierry Montel, so I'm VP of Global Distribution and Key Accounts at GelSight. We have seen during the previous webinars how different surface features like dents, scratch, pits, or particles can easily be measured using GelSight portable systems. During this webinar, we will focus essentially on the capability of GelSight to measure those surface defects on any kind of material. And you will see that Abby has selected materials with very, very, challenging optical properties, and we will see how GelSight can overcome these difficulties. Typically, our customers deal with a wide variety of materials, like metallic materials, essentially, aluminum, titanium, steel, but not only. Some of them are dealing with carbon fiber, glass, transparent acrylic, gems, abrasive materials, even human skin, and in some cases, fish scales, reptile skin, snow. So you see a very wide variety of material. We have customers manufacturing spacecraft, aircraft engines, which utilize, many different materials, and for which the accuracy and repeatability of their analyses are really essential to ensure, the safety of their product. We have also, customers in other domain measuring very thin coatings, on highly reflective materials like glass or, highly shiny metals. Laboratories studying the ability of fish and reptiles to evolve in their, environment, and needing to analyze in very detail the structure of the scales of the fish and the skin of the reptile. And probably one of the most emblematic, application we remind on a regular basis is the use of GelSight by several national Olympic teams, ski teams, to measure the roughness of compacted snow and to adapt and to optimize the friction of the ski on the snow. So this just to give you some example, highlighting the large variety of application and materials for which GelSight brings, we believe, really a unique solution due to essentially, the way GelSight is working. And this is exactly what Abby will briefly present you just now, how works our technology, and will illustrate the use of GelSight mobile system on different materials. Now it's time to give the talk to Abby. Thank you, Abby.
Thank you, Thierry. So I have our Series 2 system here, and we'll just start with a little bit about how it works, and then we'll get into taking scans and reviewing some of different materials. So I've got our Series 2 system here, and what we're doing when we click this button is actually taking 6 images, and behind the gel, I have 6 banks of LEDs. So actually, I'll change the slide here to kind of help illustrate this. There we go. So that we can explain what's happening. But basically, when we click this button, we take 6 images, one from each one of these different lighting orientations. So there's one camera, but 6 banks of LEDs. And the first step is acquiring all of those. And the next step is actually building the normal map and then generating the 3D height map from those. Now, when we have that in conjunction with our gel sensor, that's what's going to let us look at any surfaces regardless of our optical properties. So I'll actually stop sharing this slide now and talk a little bit more about the gel, and then we'll take some scans. So we've got our gel sensor here. And the gel sensor is soft, so it's kind of the texture of your fingertip. That's the idea there, or the hardness of your fingertip. And it also has a pigment layer on it. And we're actually taking scans of surfaces by pressing this onto that and looking at it through the other side of that pigment layer. So that's why glass, metal, textiles, snow all looks the same to the GelSight system, because we're looking at it all through that red pigment layer. So I'll just add this gel cartridge into my probe here, and I'll share my screen to show the GelSight mobile software. So let's jump over to that over here. All right, and now we should be able to see my software here, and I'm just going to press my fingertip into the gel to give you an idea of the resolution, something relatable. So after showing that, I think we're ready to take some scans, and we'll start with transparent materials. Thierry mentioned that, as you know, it's a challenging application for a lot of other technologies. So for this first example, we'll look at a defect on a phone screen. So we'll jump over to this video over here. And there is a defect on the screen. I'll just press the gel onto the surface, and we can see that there. And I'll click the button to take the scan. We like this example. Consumer electronics is one of the first applications that we have, commercial applications for GelSight. I'll open up this scan that we just took. And let's look at it in 3D. So we'll click on the 3D button here. Maybe enhance the scaling so that we can see that defect a little bit better. And we'll jump back over, and I'll just show an example of some analysis that we might do on an application like this. So in this case, I'll just do our defect detection function, which we talked a lot about in our scratch and defect webinar. So I won't go into too many of the details, but there we just generated the characteristics of the defect in our field of view, and then we can even turn this into a PDF report. So transparent materials can be are typically challenging for a lot of other types of measurement systems. And Thierry, maybe do you want to elaborate more about applications on transparent materials, even in aerospace or other industries?
Yeah, it's interesting that you cite the case of the smartphone, because it was one of the first custom application analyzing the edge break on the smartphone screen. No technology was really able to measure micron level features, and GelSight was the only one offering these possibilities. So it's interesting to see that this is really a very practical use case. More recently, we have been in contact with companies manufacturing, canopies for jet fighters, or, cockpit windows. And same thing, when you want to measure, scratches, dents, wear, on this kind of material, it's extremely challenging, and it's also challenging and very important to be able to quantitatively measure any kind of defect on these critical components. And we know that, classical technologies based on interferometry, structured light, have enormous difficulties, with the highly reflective or transparent materials. And if you use a profilometer, with a needle, you will just, scratch your material, and it's not exactly what you are looking for. So GelSight once again brings a unique solution.
And I thought it would be fun to share actually the first scan that I ever took at GelSight when I joined the team. So I took this scan here, and this is actually a tip in the windshield of my car. So this is the first scan that I took, and it's a good example of transparent materials and the use of GelSight on that. Just measure this as a scratch, for example, to get the deepest part of this defect.
And yes, and when you have a defect like that, you can really measure, the depth of this defect and take the decision if you need to replace this windshield or not. And this is really typically, the way GelSight is used by, manufacturers of canopies and aircraft windows, for example. Very good example.
And another challenge, specifically with transparent materials, can be coatings, and on top of that, for other systems they might end up measuring through that coating as opposed to measuring the surface of that coating. And GelSight is only going to measure exactly what it touches. So we will always be measuring that top surface, whether that's the coating or the material below it, as long as it's the top surface. And then I did want to show, we'd already talked about snow. We mentioned it in the particle and pit detection webinar, but of course it's one of our favorite applications. So I had to share the scan again. But this is a scan of snow, and we could use our analysis functions here, like to look at the particle size distribution, for example, of these of this melting snow. This is the end of the season over here for this one. All right, and then the next kind of category of, I guess, analysis that we wanted to talk about is interfaces of materials. So, we talked about the defect on the smartphone, but we could also talk about the interfaces between materials. So we have we have on this phone where it switches from glass to metal. And that can be a typically challenging application for a lot of other measurement systems as well. So actually, let's jump over and I'll take the scan of that here. And I'm just going to press the gel onto the corner of this surface. So this is the interface on the side of the smartphone, going from glass to metal around the corner. And you'll see that there's no difference to the system, whether we're looking at glass or metal in that scenario. So we can come over here and let's just take a look at the profile around that corner. Something like this. And we'll come in and we'll define our reference surface over here. And maybe we're looking at the profile, or maybe we're looking at something else. But this is just an example of looking at that interface between those two materials. And Thierry, maybe I think you had a good application where you were looking at two different materials that you wanted to talk about.
Yes, composite material are really also something challenging. I was visiting, MRO shop of a very large, airline, and they were interested to measure, the wear at the root of, a carbon fiber fan blade, which is once again, a very critical element of an engine. And they had an interferometer, installed to measure these wear. And this technology was simply not able to see the surface and represent the depth of these wear. I just took the mobile system, took a scan, and after 1 minute we had the depth of these wear. It was absolutely direct. And interestingly, since you are talking about multi-material, on the same part, you have the leading edge, which is in titanium, and the body of the blade, which is in carbon fiber. And it was extremely easy to measure the transition between the leading edge in titanium and the body of the blade in carbon fiber. The presence of resin was absolutely not a problem for GelSight. Thank you, Abby, reminding me.
Right, and I think that there are some optical systems that can handle that, but you might end up needing to have different light level settings, and basically you're going to be doing a lot of image stitching to stack those images together to prevent some data loss, and that can be pretty time consuming versus just a matter of seconds of taking a scan with GelSight without having to change any settings between material types.
Yeah, you're right. The calibration, just to remind also, the calibration of GelSight remains the same for any type of material. You don't need to redo things if you switch, from glass to carbon fiber or to textile or fish scale. It's always the same setup of the system.
Yeah, and then another example that we have of looking at two different materials, we actually have an example here where we're looking at an adhesive on a paper product, basically. So I've got this scan here. You can see the adhesive strip here, and we could this is basically applied onto this paper product. And we could even just measure, the height of it, something like that. So it doesn't matter that this is, an entirely different material. This would be actually pretty reflective and kind of sticky, but something like this to get the height of that. Now, in addition to looking at materials that might have different optical properties in the same scan, we also have, applications where maybe we're looking at really highly reflective materials, and that can also be challenging as far as concerns about damaging parts and other issues like that. So we have a good example here that's actually of a watch. So obviously, if you've seen a wristwatch, they're highly polished, so this would be a really reflective material. And maybe if we wanted to read the text or something like that, I'll actually just use the pit detection algorithm here to highlight the text. But then maybe, Thierry, you could talk about this type of application.
Yeah, this is another interesting application for GelSight. Basically, we had contact with companies, interested to automatically read, these type of characters, which are typically part numbers, serial numbers on very highly reflective material. Most of the time, those characters are very, very small, and it's very, very tiring for the operator to continuously read those codes, and it can potentially lead to errors which needs to be addressed subsequently, of course. And what we have demonstrated is just by taking scans of this part, it was easy and really straightforward to analyze the image generated by GelSight using existing cloud services. So in just a few seconds, we were able to give very precisely the chain of character which is engraved on the component.
Right, and then so obviously this is one example of a highly reflective surface, but we've also seen in the field silicon nitride parts, for example, that might when you're looking at it with an optical system, the wavelength that you're using might be getting absorbed by that system. So we can definitely see some challenges for those types of materials for just based on their reflectivity and what wavelengths they can absorb. So obviously with GelSight, we're looking at everything through that layer, so we're not going to encounter an issue along those lines with that. And then I have a kind of a classical example here, switching gears. We're looking at really smooth polished surfaces right now, but we could jump right over to looking at very abrasive materials. So I have a sandpaper example here. We'll jump back over to capture. And we'll take a scan of this sandpaper here. And we can see in this scenario, abrasives can be a pretty challenging application for other systems because of the high slopes that we're looking at. So actually, the rougher the surface, the more challenging it can be for some other systems here. The other factor too being, we're looking at a larger field of view than some systems, looking at about 14 by 17 millimeters. So to get this resolution with this field of view, you might experience some data dropout with some other optical systems here. But we could just go ahead and measure, maybe we want the surface roughness of this abrasive material. We'll go ahead and set that, and we'll analyze it. So I just showed the surface roughness analysis for this, but we've also done some other analysis of abrasives with AI that maybe, Thierry, do you want to talk about one of the applications that you did with that?
Yeah, there is essentially two usage of GelSight for abrasive material. The first one, when you have a new grinding wheel, for example, is to be able to control this grinding wheel to avoid particles or grains which are higher than the others and which could generate a mark at the surface of your part. So it's very important to be able, like you did with the surface roughness tool, to be able to determine the highest particles and just to make sure that it's within the spec of the grinding wheel. This is a first application, and the second one is to measure the wear of the grinding wheel, and it's not always easy to find physical parameters or quantitative parameters to classify the different level of wear of a grinding wheel. And typically the AI module, which is based on machine learning, basically can be a very powerful alternative to classify the wear of these product. And this is once again a second way of using GelSight, which can be not straightforward, but which is extremely powerful.
Thanks, Thierry. And I have another example here that we'll take a scan of that has similar challenges to abrasive materials, actually textiles and fabric. They also have these high slopes that can make it hard for other systems to, have all of that, I guess, the required resolution at that height range that they need. Also with that field of view requirements. So I'll jump back over here and we'll take a scan. This is actually a peel fly composite material, and so it's a woven fabric, and I'll just take a scan of this. And you can see the structure of that fabric, so I'll let that generate, and then we'll take a look at that scan here. All right, so I've opened this up, and this also might be something you'd be interested in surface roughness for, or even just the 3D reconstruction of this in general. And I mentioned, the similar challenges because of the variation in slopes and textiles, but also with the stylus. This is a soft material, and a stylus might drag the fabric across the surface as opposed to moving over it, right? So GelSight, we are a contact-based system, but it is a very soft gel. So you aren't going to be kind of dragging the material in other directions while measuring it. And then kind of to switch gears from these types of materials, we do also have some applications where the geometry can also play a factor in the challenge of measuring that part. So we have one of our favorite examples here. We'll actually jump back over to capture again, and we'll look at the edge of a blade. So I can see that, hopefully you can see that sitting on the desk here. And we've got a defect on the edge of this blade here. And I will take a scan of that. See that one there. So we can see that defect, and I'll take that scan. This one's another good one, actually. We'll take a look at this one. And we'll let those generate. So Thierry, maybe you could talk a little bit about the challenges of I guess the edges of parts, what might be challenging for other systems too.
Yeah, this is typically the case. What you have scanned, it's typically the kind of defect you can find on a blade, on a leading edge of a compressor from a helicopter engine, aircraft engine, or even a power generation turbine operating in a dusty environment or in a sandy environment. It's very easy to for the engine to suck a stone or this kind of thing. And basically, this is the result of what you will have on your blade. And when a maintenance person sees this kind of defect, of course, you need to measure it. You need to measure it very accurately, and the depth is very important. But not only. Locally, you can be very interested. Sorry, to measure the radius. At the bottom of the scratch, to make sure that you will not initiate a crack, which can propagate very quickly. Through the profile of the blade, and of course, if you lose a blade, it will lead to a very bad situation for your engine. And once again, it can be an aircraft engine, and if you lose one engine, the aircraft has some difficulties. And if you lose your power generation turbine, so part of an island can be without electricity. So the consequences can be extremely bad. And the fact to be able to quickly measure this kind of defect is essential. And once again, when you look at the surface of a compressor blade, it's optically challenging, very challenging, and also due to the fact that the 3D shape, the local 3D shape of the blade.
Right, and the portability of GelSight really comes into play here. Accessing these locations, and also seeing some other technologies used in the field that are pretty hard to set up to look at edges of features. Maybe if you do have a portable system, it's challenging to keep whatever you're using, stylus or probe, at the correct working distance to the defect. I know that can be a challenge for other systems there too, as opposed to just pressing it onto the surface. And now we wanted to wrap up with some of the other biology-related applications that Terry mentioned that I think are kind of fun ones. So obviously I don't have these to scan live, but I'll actually pull open a scan here, and we'll take a look at, this is a fish, and we're looking at some fish scales here. We got really nice detail out of that. Some other applications in the biology world, this was a preserved sample, but we've also looked at some live samples as well. Like we shared this past year in our Did You Know series about someone using GelSight to scan live frogs. So, preserved or live, it is a non-destructive gel sensor that's soft enough to do that too. And we'll jump over to capture for this one. But for this one, we'll just look at the back of my palm, for example, the back of my hand here. And we do have applications looking at skin directly in cosmetics, and also just in 3D rendering of different surfaces. So Terry, I don't know if you wanted to add anything to that too.
Yeah, measuring fish scales is something which is extremely interesting. I had to do that, with a team in the University of Los Angeles. It was very, very exciting. And so a few years ago, I was also in contact with, a researcher from the Museum of Natural History in Paris. And he was typically, scanning fishes with a very high degree of detail. He was generating STL files from those scans, making the assembly of those STL files, and then 3D printing, the surface from these STL files, and studying the hydrodynamics of the sample he was generating on a wind tunnel. So you can see that from a simple scan generated by GelSight, you can study the hydrodynamics around the scales of a fish. So a wide variety of application, and it's just to show you the limitless possibilities of GelSight. Very interesting case.
Yeah, thanks, Jerry. Do you think you could also maybe, so this was the last scan that I wanted to go over. Do you think we could kind of summarize, some of the value brought by GelSight and other challenges that we've just talked about?
Yeah, I think everybody knows that as soon as you have a very reflective or transparent surface, it's very, very challenging to use classical technologies based on interferometry, structured light, or even profilometers. So there is no easy way to do it. And once again, what GelSight proposes is really to be able to scan any type of material. Beside GelSight, we can always mention the possibility to take a replica, a mold of the surface, but it's not really practical. It's time consuming, and when you see the value brought by GelSight, in doing this kind of measurement in a very, very short time, I think we really bring something which is unique for sure.
Thank you, Terry. And I think we have some time for questions now. So the Q&A should be active at the top of the screen here. So go ahead and feel free to ask some questions now before we wrap up. And we'll also make sure that we get this uploaded to YouTube as a reminder that is being recorded right now.
Yeah, just before we're waiting for the question, what we can also summarize, when we look, to the last webinars, we insisted on the capability of GelSight to measure different, type of defects. We were mentioning, scratch, dents, splits, particles. Now we really wanted to insist, on the fact that we are able to measure any type of materials. The portability of the system allows you to measure a fine blade directly on an aircraft, or to measure a fish scale in a museum, to measure snow on a ski track before an international competition. This is really to illustrate the value brought by GelSight on their on its mobile system, and also with a high degree of accuracy and repeatability which is demonstrated by all our customers when they do their internal studies, to be able to use GelSight with confidence. I don't know if there is any question, Frank, on the Q&A.
I'm not seeing any questions right now, so we'll just wait, I think, 2 more minutes just in case anyone's typing right now, and then we can wrap up. After this, we can also feel free to reach out to support@gelsight.com with any questions that you might think of after this webinar.
Apparently, no question.
Well, I think we did cover a good variety of materials. That was kind of the goal here. So I hope it was at least fun to see different types of surfaces using the GelSight system for everyone that is attending. So, all right. Well, I think with that, we will end the webinar here.
Yeah,
So
thank you, Abby.
Again,
thank you,
all.
Frank.
Yeah, thank you all for joining.
Thanks.
Bye.